What is distributed energy resources? Distributed energy describes the vast array of small-scale energy technologies owned by consumers like rooftop solar, home batteries, electric cars and their charging points, and smart appliances like heating, cooling, or cool pumps that can communicate to each other and respond to signals from the grid. Currently, a quiet energy revolution is taking place as more and more people invest in these technologies. Rooftop solar, home batteries, and other innovations are putting power in the hands of the consumers and help them coordinate and control energy use. These technologies can reduce power bills and collectively may transform the energy system. As these technologies are being more and more implemented, households and businesses will be less and less reliant of big power stations. This results to challenges like how to manage the voltage or how to predict the supply and demand. Distributed energy resources can help businesses and homes run more efficiently by creating on-site storing and use energy at peak operating times. For example, the use of alternative energy sources like solar and wind, which produces electricity, energy storage unit to store it, an inverter, and control unit to control the distribution of electricity on site. These alternatives are used for longer productivity during grid power outage. But when the sun goes down or the wind stops blowing, those energy sources are gone. Adding energy generation and storage resources frees the consumers from the grid and allows them to operate in. The key to this process is having components for the electricity to continuously operate using these alternative energy sources. Since the energy that most alternative sources produce is direct current, and most facilities and homes require alternating current, this results to a need of inverters. However, most inverters are designed to not operate during the grid is down. This function is for safety purposes of the facility personnel. For the microgrid to continue operate, the inverter must be an island inverter, which is designed to operate on its own without being connected to the grid. Another component is the control unit, which acts as the distributor of the electricity to the different loads on the site. This delivers the stored energy and distributes it on the time of peak demand. This results to reduction in electricity cost of the utility. These components are needed in the microgrid. These are the steps to make a microgrid. First, conduct a thorough energy assessment of your facility. Make a list of where your facilities need energy improvements such as increased reliability, lower emissions, or reducing the peak demand charges. Obtain a full year of electricity bill data. Assess where and when peak energy use occurs. Confirm that the facilities in question are under your control. Determine if there are any barriers to making the energy improvements. Regulatory barriers, local permits and codes. Consider what you need in distributed energy resources to achieve improvement goals. What equipment is needed to achieve energy improvement? What levels of power are needed at what time of day? What is energy producing capacity of the equipment and what conditions are needed for operation?